Hello, this is Group 15's project on anechoic chambers. Anechoic chambers are rooms designed to prevent sound or electromagnetic wave reflections. Often, they are isolated from outside energy sources, causing people inside only to hear direct sounds. Being in an anechoic chamber can have a disorienting effect on the senses, generally causing people to listen to sounds that are normally internal to one's body. These can be sounds such as a heartbeat, bones grinding as a person moves, and a ringing in one's ears. The term anechoic was introduced by acoustic expert Leo Beranek during the construction of the chambers, with a vision that extended beyond purely acoustic applications. Early anechoic chambers were designed to test spherical propagation angles of acoustic waves in specific media, ensuring no sound reflections interfered with the monitored waves. These early concepts laid the groundwork for the diverse scientific and industrial applications of the anechoic chambers seen today.
The Murray Hill chamber, built in 1947 at Bill's lab, was the world's first wedge-shaped anechoic chamber. Designed with fiberglass wedges, it's achieved over 99.9% sound absorption for frequencies above 200 Hz, enabling almost completely echo-free sound testing. Renowned as the quietest space of its time, this innovative chamber set a new benchmark in soundproofing and experimental precision, inspiring further advancements in anechoic chamber designs. Orville Labs' quiet chamber, recognized as Guinness World Record as the quietest room ever built, achieved a reading of -9.4 decibels before 2000, updated to -24.9 decibels in 2021. Used by NASA, the chamber simulates the silence of space where sound cannot travel due to the absence of a medium. This environment helps astronauts adapt to extreme silence, enhancing their focus and emotional resilience during missions where psychological stress could pose risks. From the 1950s and onward, anechoic chambers expanded from acoustics to radio frequency and sonar testing, driven by technological advances and the need to address electromagnetic interference. These chambers enabled precise testings of antennas, radars, and loudspeakers in interference-free environments, allowing accurate measurement of sound quality, directivity, and frequency response.
So how does it work? The anechoic chamber is composed of sound-absorbing materials that surround the entire room, with the goal being to completely segregate the noise levels from outside sounds that can affect the noise levels within the room. With sounds having the ability of being absorbed, reflected, or carried on, the anechoic chamber focuses on making sure to completely absorb sound so that the levels are at a complete lower than what the average human is used to. The average decibel levels of your room at night would be around 30 decibels. However, being in the anechoic chamber, this could be brought down to low decibel levels, potentially being in the negatives, like in the lab in Orfield Laboratories in Minneapolis, Minnesota. A human ear can perceive sounds above the noise level of 0 decibels. However, these anechoic chambers go below those levels where a human's ear cannot decipher due to the passing of that threshold, unless using equipment to measure that produces little noise itself, as observed in the anechoic chamber at the University of Salford, going down to -12.4 decibels. Using these types of materials inhibit outside noise and intrusive electromagnetic waves from coming into the room into a completely silent room where one's voice does not echo or carry out. Anechoic chambers can be built with a range of layered materials that deplete sound, such as steel, concrete, or even fiberglass, which are all tools that are known for their density. Due to how these rooms can be quiet, it can be very unsettling for many people due to the lack of external sensory input. To demonstrate just how depleted the noise levels are in an anechoic chamber, take a listen to this balloon popping and decipher how drastic the change is.
Researchers use anechoic chambers to study how people hear and locate sounds. These chambers can be big or small depending on their purpose. Today, they help test technologies like 5G and LOT devices by creating controlled environments for high-frequency testing. They also help with testing microphones, speakers, and hearing aids, improving product accuracy. Companies use them to measure noise levels and stimulate sounds like rain on a roof. Researchers can change variables in the chamber to see how people respond to different sounds, helping us understand how the brain processes sensory information. This controlled setting shows how the lack of echoes affects thinking and perception. Anechoic chambers are used to study hearing by removing echoes and outside noises, allowing precise measurements of hearing and sound localizations. They are also used in studies of touch, where the lack of echoes makes it easier to feel vibrations and textures, giving insights into how we process sensory information. The lack of echoes can mess with the person's sense of space, making them lose balance. This can lead to problems with stability, especially in places where sound cues are important. It can also affect concentration and focus as the brain struggles to process sounds without the usual environmental cues. This can cause distractions and make it hard to stay focused. Anechoic chambers designed to absorb sound and eliminate echoes create an environment with minimal sound cues. This can challenge thinking and focus, especially for people with hearing impairments who may be more affected by the lack of echoes.
As previously stated before, the anechoic chamber is designed to prevent sound or electromagnetic wave reflections resulting in a noise-free effect. To the masses, this chamber seems like a fun, interesting, and haunting place to be in. However, along with the uniqueness of it, there are several clinical applications for it as well. Two of the main clinical applications are hearing and psychological/behavioral studies. While the absence of sound can feel unsettling, it's useful in regard to hearing and hearing loss research because it gives the researcher confirmation that the test that they are giving will not be affected by outside sound variables in the testing environment. At the University of Memphis, Dr. Danny Johnson, an assistant professor of audiology and the director of the Hearing Aid Research Laboratory, conducts research that focuses on hard of hearing listeners' performance with assistive listening technologies like hearing aids by using anechoic chambers to quantify the participants' listening performance and categorizing the performance of specific components and digital signal processing algorithms. As of 2024, the study is still in progress, so results are yet to be released. Despite the release of results, though, it's still relevant as an example to how anechoic chambers are being used in contemporary studies. In addition, there was a study that investigated whether musicians show perceptual advantages in cocktail party speech separation in a competitive, multi-talker environment through the use of anechoic chambers, since they were able to manipulate the sound that participants would receive. The relationship found was that those with musicianship have better, faster cocktail party listening with 200 to 400 millisecond speech recognition speeds in comparison to non-musicians. However, they also noted that they believe cognitive factors can partially drive the musician's advantage. What's more, anechoic chambers are also used in psychological and behavioral studies. Due to its unsettledness, the sound that people's bodies make becomes amplified, and people often state that they hear this hissing sound from your breathing lungs, your heart beating loudly, and a low-pitched hum from your ears. One study used in an anechoic chamber to test whether fear influences phantom sounds, percepts, and if factors like anxiety would affect it as well. The results showed that people with higher levels of anxiety and noise sensitivity often perceive tinnitus more unpleasant and louder than those with lower amounts. As you can see, the environment where sound is absent can be beneficial for many testing reasons regarding the sense of sound and the psychological and behavioral effects that the overwhelming silence can have. Thank you for listening to our presentation. Here are our references.